and thank you for being here. I've been trying to put together everything that the measurement people have been saying in the past few days. And at the same time, I wanted to, because I know you have various levels of understanding of physics, I wanted to make sure that at least to a reasonable level, I give you background so that you can understand the data and think through it for yourself, rather than just an expert telling you, okay, this is this and this is that. Another goal that I had in mind is to open up the questions, because a lot of you asked really good questions in the breaks and in conversations with me, and I realized how open-minded this beautiful crowd is. So I will try to help you share some of my own, and that might prompt you for more of yours. So, see, the beauty of science is it's a never-ending process. You get one answer, you open 5 more answers, and then it goes on like this. And so the goal, I decided to start with the conclusion. I stole this from Goran, right? So I will be opening up a lot of questions, and I don't want to sound as if I am questioning everything we did. So, to my mind, we clearly established what we shared this morning at the conference. These are not natural structures, they're man-made, and now the question is, for what purpose, who did it, when, how, and so on, and we don't have clear answers to just about any one of those questions. We just see that these anomalies are not something that you find around. So, with that in mind, let's ask good questions. How about that? So, when we've been out there, you could see, you could see, situations of this kind, and then you have, to make it worse, you have this fishing pole, sounds very fishy, So, we'll try to sort out some of that lingo, and we'll see what kind of answers the whole thing is. Yeah, it's a bunch of people. I'm not going to repeat all of them, but they're doing a variety of different measurements. Specifically, a lot of them are doing similar things with electromagnetic waves, but we had also sound waves. We had current, and then previous recording of radioactive activity, and Dr. Korotko was measuring the energy of the space. So I decided to start with him because he seemed like most straightforward in terms of his findings. The device that he used, that he calls BioWell, I would love to understand fully how the device operates, and I asked him, of course, the questions, but there's always more questions to ask. Now, this morning I asked him, okay, let me make sure that I understand it enough so I don't say anything incorrect, and that I say enough. Okay, so we agreed on that. So, before I tell you what few things about the BioWell, you saw the shapes of the auric field that they've been measuring here in Visoko. I want to tell you that there's something that's equivalent, because he said it's not electromagnetic. It's not of electric and magnetic origin, but some other kind. I want to tell you that there is something that is looking just like that, and that is electromagnetic in origin. And this is electromagnetic field that our heart is generating. I will try my best to explain to you what electromagnetic waves are and how they originate. But in short, every time you have an electric charge moving, that creates a pulse of electric and magnetic field. Electric charge has a space around it in which other charges feel the presence of it. And that's called electric field, so electric space if you want. Now, when the charge is moving, that also creates magnetic field, which is what you know commonly from the magnets. And when the charge is moving, you have combination of the two, and that goes out in space as electromagnetic, what we call electromagnetic wave. We'll be later on dealing with the frequencies of those waves. But the heart is an amazing source of electromagnetic waves, because every time the heart pumps, or every time the heart beats, you have the motion of, like a surge of electric current through the muscle that is necessary for the muscle to contract. You want the muscle to contract, to pump the blood. So you send electric current through it. You know that muscles contract when electric current is passing through them. Heart does just that. In the process, we get electromagnetic pulses being sent out into the space. So the field that you can measure around looks just like what you saw in the presentation that Jasper and others were showing before. So when he says it's not electromagnetic, my first question is, why not? I mean, to my mind, and on top of that, he's measuring it through the electromagnetic field. So why do we assume it's not? I did not get that answer from him. I'm opening questions, okay? Is that fair enough?
Yes.
All right, good enough. I want to say that brain also does the same thing. Actually, every cell does the same thing, but not as strong as heart. Heart does it about 5,000 times more than the brain. The strength of the field of the heart is about 5 times greater than the strength of the field that the brain creates. And that's one, if you want to find the secrets of the universe, think in terms of the energy, frequency, and vibration. You have them all right there in your heart. You don't have to go to the outer universe for that. And another thing that's really interesting, I'll get back to that, is that our state of mind, our state of emotions is heavily affecting those waves. And there is a simple instrument that I got from the company called HeartMath. You connect this thing underneath your earlobe, and you can then connect it to the computer, and it records your heart pulses, but then the software analyzes how coherent those pulses are. So the coherent means how similar one pulse is to the other one. Make sense? How similar they are one to another. Because if you're in nice state, in pleasant state, in harmonious state, in peaceful state, meditative and all of these other words, then the heart is beating so that you have the beats very similar to one another. And this is how the resonance wave looks like. And if you're nervous, if you're upset, if you're angry and everything else, then it looks like that. It looks just like noise. This is how the noise sound looks like. By the way, these are both my heart waves. Both of them, the nice one and the bad one. And the funny thing is, the upper one is nothing really bad. I was just preparing presentation. I just got few data points. This is pretty much how we function if we are not in calm state. I'll show you more data on that later on. So my idea was, and I did not want to share this before I even try. My idea was to just try this, give it a little bit of a trial before possibly moving on, and record. And I did that with Helena. We tried it outside the tunnels, and then inside the tunnels, and then again outside the tunnels. And we realized that the bigger effect had the state of mind, and as she was going along, every time it was better and better, no matter where she was. So the kind of first take on that is that it matters more what you're doing than where you are. But it may be something also to later on try on. So the BioWell, again, is the device that is measuring, let's call it electromagnetic field of the person. And when it does that by scanning the body, Dr. Korotov said that it's measuring joules, meaning it measures the energy of the body. And then you can scan, of course, how well the person is doing, and we saw some really, really interesting data on how that positively affects the body when people are spending time in the tunnels. Now, he was also using it as we were going around, and you saw the data before. What we observed in the pyramids, that the energy level is going up as he was going up toward the top. When he was on the tumulus, he also saw very high levels, very similar to the levels of energy that he saw on pyramids elsewhere in the world. And he said several times that there was a person who told him, "What about the other hill?" I was that person. So, because on tumulus you have because previous day we were talking maybe the sun is affecting it. Well, let's just go to the next hill down there. It's same altitude, just 50 meters away, and then we will know if it's sun, and we don't even have to talk about it. And he measured significantly lower level of energy on the neighboring hill. so they are saying, that we need to introduce here another concept called ether and scalar waves. And I'm kind of reluctant to jump on the bandwagon. So they'll say it's not bandwagon, but hey, because this is not even in scale. This is just a tiny dot compared to the whole pyramid is tiny dot compared to the wavelength that we are talking about. So I would say that that's not the mechanism. Now, the classical physics, not classical, but conventional physics is recognizing that vacuum is not empty space. Already now they're saying vacuum is not empty space, and ether kind of feeds to that idea. Ether says that there's no empty space, there's this, omnipresent stuff that electromagnetic waves are, traveling in. By the way, physicists thought so about 130, 40 years ago. And they created an experiment called Michelson-Morley experiment. I'm not going to get into that. But that experiment dismissed the ether according to their interpretation. According to their interpretation, and I don't see faults in that experiment. I don't see faults. You'll tell me if you do. Okay. But the space is empty. The physics is recognizing this now. The stuff is coming up from something that we think of as non-existence into existence and popping back down. So that's not inconsistent with conventional physics, and we may be able to use something that's already there. There's a bunch of experiments that show that vacuum is full of energy. I also do recognize that we are really limited in how much we understand and how much we can perceive. Electromagnetic waves are just one example. We see only a tiny fraction of what the electromagnetic waves are. And imagine this experiment. So we do not see those waves at all. In addition, the atmosphere is blocking the X-rays and gamma rays really high. That's a good thing because being exposed to them is not good for us. So the atmosphere is blocking them. Now imagine a person who puts here the detector for gamma waves, points them to the space, detects nothing, and says, there's no gamma rays coming from the space. See, there'll be faulty conclusion, right? So we have to explore everything up, back and forth, down and right, before we say something doesn't exist. And if you put it in the satellite, the detector, then you do detect it, right? So this is why I've been kind of, talking with my colleagues, I've been saying we need a whole lot more of systematic and continuous data collection to draw more conclusions here. Here's another kind of kicker. You saw the electromagnetic spectrum. We see just nothing out of the whole thing. Our senses don't. And when you put the diagram of what physics today thinks the universe exists of, see, the ordinary matter is about 5%. What we call dark matter, which is responsible for weird motion of the stars, is about 25. And then dark energy, which is responsible for weird expansion of the universe, and we don't know what it is, but we just call it dark energy, is another 68. But see, the whole electromagnetic spectrum is not even on the chart. The whole thing that we don't see a fraction of is not even on the freaking chart. So this is how little we know. This is how little we can perceive. So let's stay open, but not jump the hoops. Yeah, that's kind of invitation. You know the story about the elephant? The blind man describing the element? Yeah, physics is like that. It's a wave, it's a particle, it's matter, it's energy, it's probabilistic, it's deterministic, this and that, right? But all of that applies. And physics has situations when it's both. When something is both, when light is both wave and particle, when stuff around us is and matter, energy and matter. Right? Seeing from different perspectives, if you take both perspectives, you get a better idea of what you're looking at. Is it this or that? Or it's something completely else? Right? And physicists are not shy in venturing into other games. Physicists, these are all physics professors. All of these books were written by physics professors. Combination of physics and spirituality. They're not shy doing that, but when they do, they're careful about stating the game they're playing in. I talked we had a wonderful discussion this morning, Jesper and I, and when he went to Ether, I said, okay, but we are now playing different. He asked me, do you believe in soul? And I said, okay, now we are changing the game. And I'm okay with that, but we have to agree that we are now not playing basketball anymore. We're now going to play football, and it's okay to kick with your feet now. So I'm okay with that, as long as we know which game we're playing. I don't want to jump around, because you never know. If there are you see, the rules are restrictions. The rules of the game are restrictions. And if there are no real rules, then there's no game. Everybody can do anything, right? The guy can decide it's taekwondo instead of, soccer, and just knock the guy out, right? What kind of game is that, right? So if we're going to play a spirituality game, I'm all in. If you're going to play physics game, I'm all in. I don't want to just jump all over the place, whichever way anybody decides is most convenient at that moment, right? Does that make sense?
Let's go to the tennis court.
See, and this is how do you sort it? Heikki measured this stuff on the top of the pyramid. Now, bottom, he had this funky but irregular signal, right? Sharp frequency, strong peaks, specific pulse. And then he comes on the top and he just sees this noise. And we were thinking about maybe that signal somehow gets distorted to the top. But disperses. But there is, in order to test that the idea, let's not call it theory, but that idea, we later on thought, let's have a clear signal. Let's decide what the signal is. So let's stick up some frequency source at the bottom, and then record something at the top, and then we will know. Right? Then we will know if it's just being that signal distorted or is some completely random crap, right? Pardon my French. Yeah. Right? Especially because it's ultrasound, right? That should not even get there, up there, right? So the experiment, the controlled experiment, is the way to go. And I wanted to come back, here, the way to sort all of this out, just more good science, more good experimentation, and looking at things from different perspectives. I love what this guy is doing. I love what this guy. I love you, man. I love you.
Thank you. I love you too.
And I wanted to add here one more thing from physics. I just cannot resist. So I told you the difference in our pattern. So do you think it will be the same? It will be the same for you to send this stuff out to people and send that stuff out to people? No. No, there's this thing called interference. These waves come together. I showed you earlier how standing wave appears when two waves interfere on one another. You have constructive interference. These are technical terms. Constructive interference, and you have destructive interference. Right? People feel you, and you feel other people. Right? That's all physics. And this graph down there is me recording myself on this. I wanted just to take a sample because I was preparing some presentation, and this is how it looked like, all kind of spiky. It was 10 p.m., I was preparing the presentation, nothing bad happened, I don't know. I guess I'm just, nervous guy. In any case, I took that, I let a minute to stay like that, just to take the sample of the base data. And you tell me when is it that something really changed. I'm just going to go, and then you tell me when something changes. Right there, right? See, if this is a minute, this is about 5 seconds, top 10 seconds. You know what I did? I put my hand on my heart and I started observing my breathing. Yes. That's all. No mantras, nothing else. That's what Helena was doing when we were measuring her heart coherence, and that turned out to override any environmental things. People were yelling around her, and in the end, it's just like we were in the shop, so people were ordering stuff and just yelling at her. She was like total bliss and high coherence, and it was higher than in the tunnels, right? So another minute. See, another minute passes, and then I get into this. So in 5 seconds from this to that, and in 1 minute from this to that. Just by conscious breathing and hand on the heart. How beautiful is that? And you can measure it. You can measure it. And you can control it. I mean, you can control it. You can really train yourself. Few people ask me about this thing, about this peak. See, these anomalies are really kind of interesting. When I was doing this, it was about 4 months after my mom died. And I thought of her at that moment. And that one thought created that heart jumped. One thought. Now imagine if we have crazy thoughts, or this was not bad thought, but it was sad. It was, it was not uplifting. Imagine if we would do that to ourselves for hours and for days and for years. Take a deep breath. Yeah. So I'm going to give a few quick tips, because this also relates when we were in the hole. Somebody, I think it was you, Goran, who did not measure any electromagnetic radiation inside, but just outside you did, or was it somebody else? I'm not sure. And we then postulated if the hole is some kind of Faraday cage.
Yes.
Yeah, so right inside the hole, there was no electromagnetic field. Just outside, it was relatively strong. There is this phenomena that if you have two charges interacting like those two, one exerts the force on another. But if you put around this guy a metal cage, then this one, when it comes from outside, it causes, the nature arranged it like that it causes other charges to distribute themselves so that the electric field inside the cage is zero. So they just kind of go around, find their places until they feel no force, and when that happens, the electric field inside is zero. And so inside that cage, you don't feel the forces. Electric field inside a conductive wiring structure is equal to zero. So what you can do here, hold on, my hand got. So what you have here is just kind of crazy thing that you can have this cage that can protect you from millions of volts. This is why it's safe to be in the car when it's lightning, but not in convertible. And so when I was in India, when I went to like New Age store, one thing that they were selling are copper wires, copper circles that you put like small one and then a little bit bigger one. Sam, you can make this a product to sell here. So smaller one that comes on top, and then a little bit bigger one, and then a little bit bigger one, and you get these 3 rings around your head that then create Faraday cage for your head while you're meditating. Right? You can just put that on the head, and you have the protection. And this is what we saw here. So we were like, what the heck is happening here? How it can be zero inside? Is this some kind of Faraday cage? How can stones create Faraday cage? Right? That was just like mystery. I mean, I'm not giving this as an answer. I think I gave you enough for you to appreciate the how perplexing it is to sort it out. And then I want to really briefly tell you, so that you know what is going on when they tell you it's been radio gauged, the age or something. And up there we had 2 measurements. One was 19,000 years, and another one was 26,000 years. So I'll tell you the principle, how that stuff works. So that you can again understand what it means, the uncertainty in that, and how pretty precise that stuff is. So inside the atom, you have the nucleus. Nucleus consists of positive protons and neutral neutrons. Positive protons have repelling electrostatic force, right? Just one that we described. They try to repel one another. They're pushing one another away. Neutrons are neutral. They don't interact electrostatically. But all of them have another force that keeps them tied together that physicists call strong nuclear force. Strong nuclear force keeps them together. Now here's the kicker. The strong nuclear force acts only on very short distances. So if you have a large nucleus, then they're far apart, these protons, and the the electrostatic repulsion can overcome the strong nuclear gluing, if you want to call it that way. Does it make sense? All of them are glued together when they're close, but when they're far, protons start to repel one another, and because the electrostatic force is not diminishing fast with distance, but strong nuclear is diminishing really fast, then you can get unstable nuclei. Unstable meaning it wants to disintegrate. It wants to fall apart. This is what we call radioactivity, natural radioactivity. Why radioactivity? Because when that happens, when they see these guys are strong nuclear force will keep these guys together, because it's much stronger than the electromagnetic repulsion. But these guys are in trouble. This is why the stable nuclei, if you have larger and larger nuclei, you need to have more and more neutrons to be connecting, glue, right? You need to have more and more neutrons because they're neutral. They're only gluing, they're not repelling. In any case, when the disintegration happens, then you have three kinds of products. And you've been hearing about beta radiation and gamma radiation. Those are two types of those products. Gamma, people didn't know what they are. They just observed as these particles went through the magnetic field. The magnetic field was pushing one of them up, one of them down, and the other one was not affected. So they called them alpha, beta, and gamma, just because they didn't know what they are, and they named them. Later on, we found that alpha is helium nucleus. Gamma is just a photon of light, very highly energetic, and beta is electron. This is what Dr. Ferris was measuring when he was here. So how this stuff works. We never know if you have a radioactive element, like radon, uranium, carbon-14. You never know when will next nuclei disintegrate. But there is a pattern. There is a strong, unchangeable pattern that for various elements, after a certain time, half of the original sample disappears. So if you have a kilogram of, let's say, radium, 1 kilogram, radium has so-called half-life of about 1,600 years, 1,600 years, half-life. What does that mean? After 1,600 years, you'll have half a kilogram. Half of it will disappear. You never know which nucleus will disintegrate when, but you know that after that much time, you'll have half of it. And then that much time, you'll have another half. That much time, you'll have another half. Are you guys following me? Yeah. Okay, so now you tell me, if I have a kilogram of radium, like, I don't know, 3,200 years ago, if there was a kilogram of radium 3,200 years ago, and now I measure that only quarter of that is left. How many half-lives did pass? 2 half-lives. First half-life cut it to half, another half-life cut it to another half. And now I have quarter of it. So I know, if I know how much I had at the beginning, and if I know how much I have now, I can then tell how much time passed. Make sense? So with carbon-14, this is what the graph looks like. So you get half and then half. Sorry, half. The PowerPoint is not the best. And you get a graph like that. And sorry. Okay, so question for you, quiz. The carbon-14 is radioactive isotope, meaning variation of carbon. And when it disintegrates, it becomes carbon-12. The half-life of carbon-14 is 6,000 years. You test the fossil and you find, okay, we already answered that. And you find 25% of it is carbon-14, and it does not change. How old is the fossil? If this was carbon-14, the fossil will be how old? 12,000 years. Right? You have to know what you started with, you have to know what you have now, and you have to know the half-life of that element. So when they are Yeah, when they are doing research like this, by the way, uranium has huge half-life of 4.5 billion years. 4.5 billion years, much larger. Yeah, I actually published a paper on this because I came up with this analogy. It's like tournament. It's like tournament. You start with all of these guys, and then after one half-life, you get half of them, and another half-life, you get another half. And so, you know, if you take a look, you know, in 9 days, you go from 16 club teams to 2 teams. In 9 days, how many half-lives you have in there? From 16 to 8 is one half-life. From 8 to 4 is another half-life. From 4 to 2 is, so 3 half-lives. And if you had 3 half-lives in 9 days, how long is one half-life? 3 days, right? One half-life is 3 days. So the half-life of a basketball team in a typical US tournament is 3 days. I published a paper in Physics Teacher on this, with this idea. Okay, so here are our measurements up there. We did not come up with very consistent data with the activity of the beta and gamma activity. Dr. Ferris will continue on that so that he has something consistent to report. But what I wanted to tell you this because a huge aspect of what we've been seeing up there was radioactive dating, right? So now you know where's that coming from. Now, how do we then, yeah, I forgot that. How do we then know what did we start with carbon-14? This is what we assume. We assume that a while ago, the ratio of carbon-14 to, we all have carbon-14 in our bodies because it's in an environment. The radioactive carbon-14 is in an environment. When we eat, we replenish it. When you drink water, we get carbon-14. So it's always we are getting from the environment. In our body, the ratio of carbon-14 and carbon-12 is about the same all of our life. And it's about the same as in the environment. But what happens when the organic body, leaf, human, dies? Then they're not replenishing it anymore. And the amount that was in the body, in the leaf, starts decaying, and you're losing carbon-14, and you're getting carbon-12. And so when you find a sample of a leaf, Samir was talking about how they found a leaf between those stones. They were able to find out what's the ratio now. And if carbon, let's say carbon-14 dropped to half of the value that we now have in the leaves, that means that was one half-life, right? If it dropped a quarter, that was 2 half-lives. And then you can tell, okay, this was 12,000 years or whatever. Does that make sense? See how elegant it is, how beautiful it is? It's just beautiful. It's really beautiful. It's logical, it's beautiful. We also had measured negative ions. That's another thing, and you saw this incredibly high values. But my suggestion here would be to continue to collect data way more consistently here. And I would even go ahead to suggest like taking a week or 2 and take it every hour and correlate that with the number of people in the towns and whatever. And then we have more things to think about. That will give us more things to think about. The thing that we saw yesterday that proposes, say again? I think you all saw the presentation tomorrow. What Jasper did, he cut off a piece of magnets into the shape of the pyramid, and he was able to explore the electromagnetic patterns around that shape. He calls that non-linear magnet because it's not just the regular magnet with symmetric poles. And he is seeing that there things that look like that. And with his measurement, whatever he was able to do, because we were just able to do a little bit of sampling, what he was finding is consistent with this. And I think that may be one huge breakthrough in understanding what this whole thing is doing. We don't have a whole lot, but the fact that it's so consistent, and it may even explain the increase of the signal as you go higher from the tip of the pyramid. I'm really looking forward to see to see what else he's doing. You remember he was changing the direction of the fishing pole, and that was to determine the direction of the field, because that played a significant role in what he's proposing. So if he's going to prove himself right, well, then he needs to check out all direction and hopefully from many different many different points. His astute observations of the rocks really baffled me yesterday, and the fact that he is funding his own research, and sending these samples to the labs is just extraordinary. And the findings that he's seeing here, that these stones have been in some way put together by ways that we cannot even not understand or even comprehend. I don't even know where to begin in thinking what they could have been that created this thing that ancient civilizations may have had in creating these stones. I asked him this morning, so do you think that pyramids were built to create source of energy for this, or they somehow created this stuff to build the pyramids with? And it could be both ways. He believes it was created somehow else, and then pyramids were created by that stuff. And with that, I would conclude my presentation. Thanks so much. Thanks so much.
Wonderful. Questions?
I hope you have questions, because the whole purpose was for you to have more questions than you did. Yeah, over here and then there.
Sorry, I would like you to ask you, did you check possibility of pollution by electrical fields inside of tunnels via cables, leads for some
Right.
devices?
Yeah.
Because as you know, via leads
Of course.
can came current, dirty electrical says dirty
course,
currents with high frequencies,
Yes.
which can make pollution.
Absolutely. Those are beautiful points. We did as much as we could under the circumstances. Jesper just arranged with Sam that he will continue doing that, and they arranged that he'll be able to get into the towns where nobody else is there, so he can plug off all the electricity. That will be then eliminating all of this. So this is exact same kind of reasoning that you want to have if you're going to have scientific exploration, right? Great. Thank you. Yes, sir.
You promised us to give us some tips about the effects of the router to diminish it.
Oh, yeah.
I thought you promised.
Yeah. Okay. No. Okay, the best thing that it's kind of funny, because earlier you could have a modem that you could plug computer into without having it wireless. And since some time ago they started creating them so that you cannot. I'm totally sure it's all deliberate, because you cannot have it. Even if you plug it into the modem, you're still having the router, emitting. So during the night it's best to just turn the whole thing off. But if you want to go an extra length, you can see what you can do to create some kind of Faraday cage around in the room. And my wife and I think, I don't know if this is too far out, but in the United States at one point they were having paints that had lead in them. And for a while now, it's like they're treating those paints as if they're the greatest hazard in that you can possibly have. Yet you have, lead being sold in any fishing, store as much as you want. And like fluoride is more toxic than lead, and they put that into water, so people drink it. And the one thing that the paint of that kind would do is to create Faraday cages. And I'm like, huh. So you're not going to find a lead paint to paint it, but you may find some other way to isolate yourself from outer radiation that you don't have control over. Like you can unplug your router, but you cannot do the same thing with other devices around. Yeah.
Sorry, just one. It is not question, but question. Comment about this. You now have special electrical devices which automatically switch off electrical during the night. That you have not when you switch off your lamp automatically switch on, but after few minutes when you switch off your
all of that can
automatically
all of that can help.
Yes.
Sure. Do you have questions? No. Okay.
I have a proposal.
Okay, proposal. I love it.
Because we love consistency of the data, as you pointed out. I'd love once if we can repeat the Michelson-Morley experiment, everybody.
Okay, so in short, yeah. So this is
that one experiment that wasn't zero, the results.
okay. So this is what Michelson and Morley did. Physicists, and you can find the textbooks of physics all the way up to 1940s that discuss luminiferous ether. That's what they called it. It's in the textbooks of physics up to middle of 20th century. For at least 80 years, it was in the textbooks. So way after Michelson and Morley. Michelson and Morley did this. They said, okay, so all the waves that we know have some kind of medium that they propagate in, like the sound waves, the earthquake waves, the water, the rope. The light is also a wave, so it has to have some kind of medium. They didn't know what the heck it is, so they proposed it's some kind of stuff that we don't understand. They called it luminiferous ether. And then this is calculation that you can do. If, for example, if you have a swimmer in the river, so river is moving, and if the swimmer goes down the river and then comes back, as opposed to going across the river and come back, same distance, it will not be exact timing. And because of the relative motion of the water, it's kind of funny, but you can show it with calculation. So they said, let's do the experiment. We are going to have a device that moves in the ether down along the direction of ether motion and perpendicular to the direction of ether motion. And so if we see the difference that we expect, then the ether is like that river, right, that the person is swimming in. And we proved that it exists. But if there is no difference, it doesn't matter which way, then we have nothing. We don't have water. We don't have it. So how do you float in ether? They decided the good idea would be to measure it as the Earth goes around the sun. So measure it at one point, and then measure it 6 months later, because if whatever the direction of motion of Earth compared to ether is now, 6 months later it will be the opposite way. So, it should have been even enough to take it to one point, but they say, what if? What if the ether is just going with the Earth, same direction, same velocity, that moment, and that blows our experiment? So let's repeat it on the other side. So, and they did. They did, and they didn't find a difference. They used really sensitive optical instruments. They used the interference, and they found no difference in different directions. Light moving this way, light moving that way. And they concluded, okay, we will work without ether. We'll say that light propagates in empty space, and these fluctuations of electric field and magnetic field generate themselves without the medium. And that's what physics is operating now with.